Continue learning about Target 1.4, which is to solve right triangles using right triangle trigonometry. In order to solve a right triangle, what they're really asking us to do is to find all of its unknown sides and all of its angles. And you can solve a right triangle if you know either of the following. If you know two of the side lengths, you can solve the right triangle by finding the other side length and the acute angles, or you can do so knowing one side length and one acute angle. Keep in mind though, we're only going to use this process if we're dealing with right triangles. So it specifies that these are both dealing with right triangles. So if we're dealing with acute or obtuse, this will not work. Go ahead and bypass this slide for now. We'll come back to that in class. All right, example 1 says to use a calculator to approximate the measure of angle A to the nearest tenth of a degree. This example is the most important because it's really the only example that has new information today. The rest is building upon what we learned earlier on in Target 1.4. So it says what we're going to do is really find the measure of angle A. Well, just like yesterday, we have to decide what we know about angle A. We know the opposite leg is a length of 15, and we know the adjacent leg is a length of 20. Now, if you still aren't understanding opposite, adjacent, and hypotenuse, that's the first place we need to look. So please make an annotation note of that, and we can talk about that in class. So since we know the opposite and adjacent, going back to our SOHCAHTOA, the function that deals with opposite and adjacent would be the tan. This deals with adjacent and hypotenuse, so it doesn't work with the opposite. And the sine function deals with opposite and hypotenuse. So again, it deals with one of the two values I know, but I want opposite and adjacent. So the only function that uses opposite and adjacent is the tan. So the tan of the angle is always equal to the opposite leg over the adjacent leg. All right, well, since I have my formula set up, I'm going to plug in what I know. In the past, I always knew this angle measure. Well, I don't know that in this example, so I'm just going to leave it as my variable, or angle A. Well, the opposite is a length of 15, and the adjacent is a length of 20. So this is the part that's new, so pay close attention to this. What we're going to do in order to find the angle is I need to isolate the angle. I can't make a proportion like I did before because I won't have enough information to find my angle. Instead, what I need to do is switch the location of the ratio, in this case 15/20ths, and the angle I'm trying to find. So the tan of 15, make sure you use parentheses here, 20ths, is equal to angle A. Now all I'm doing is I'm switching the angle A and the ratio, meaning this fraction that represents the side lengths. Now in order to do that, I have to make sure that I switch from using the tan function to the tan inverse. I get to the tan inverse by hitting second tan. So the tan inverse of 15/20ths will be equal to angle A. Now that I have the angle by itself, I'm just going to type this in my calculator exactly as it appears. So I'm going to hit second tan. That should bring up the tan to the -1. Again, that's called the tan inverse. Use your parentheses of 15/20, and then you should find that angle A, rounded to the nearest tenth, is about 36.9 degrees. Okay, so the big idea here is to find an angle. This would be something important to put in your annotations. To find an angle using your trig functions, always use the inverse function, or the tan to the -1. Likewise, if this problem was set up to be the sine of angle A, we would use the sine inverse. Cosine of angle A, use the cosine inverse to find the angle. So we're just switching this information, the angle and the ratio, and using the inverse. We'll see that again in a moment. All right, this one tells us that angle A and angle B are acute angles in a right triangle. If it helps, feel free to draw a picture. Really what we have going on here, though, is they give us the information already set up. So this is the ratio simplified to a decimal. So what we need to do is anytime we're finding an angle, we need to switch the angle with the ratio. So the sine of 0.87, by switching that, I've isolated angle A. But the really important part to remember is when you switch the angle with the ratio, you need to make that the inverse of the original ratio. So the sine inverse of 0.87 will tell us what angle A is. Well, if we use our calculator by using second sine, then we do second sine and then 0.87, we're going to find that angle A is about 60.5 degrees when we round to the nearest tenth. Again here, angle B, it tells us that the cosine of B is 0.15. So if I want to find angle B, I'm going to switch these two quantities. So the cosine of 0.15 is equal to angle B. But when I switch the angle with the ratio, I need to use the inverse function. So cosine to the -1, or second cosine on our calculator, of 0.15 tells us that angle B is about 81.4 degrees. So really, when we use the inverse function, the only time we're going to do that is when we're finding an angle measure, not a side length. All right, this particular example says to solve the right triangle. Keep in mind earlier in our notes we said to solve means to find any unknown information. So in this case, the unknown information that we have is any of the missing angles. Well, we know angle C to be a right angle, and we know angle A to be 42 degrees. So the only angle that we don't know is angle B. So that's one piece of information we need to find. When it comes to the side lengths, there's 3 side lengths, and here we only know the length of AC. So we don't know CB, I'm going to call that X. Likewise, we don't know the hypotenuse length of AB, so I'm going to call that Y. So before I do anything, when it says to solve the right triangle, I decide what I really need to find. Well, I need to find these 3 quantities. I'm going to start with the angle. Looking at this, anytime we're dealing with a triangle, the 3 angles in any triangle should add to be 180 degrees. So if I know 2 of the angles in my triangle, I can simply take 180 and take away 42 and 90 to find what the third angle must be. And in this case, it must be 48 degrees. So again, any 3 angles in a triangle, whether it's right, acute, or obtuse, always add to be 180. So angle B is 48 degrees. That would be something I would add to your annotations if you didn't know prior that the 3 angles in a triangle add to be 180 degrees. Next thing we need to do is find X and Y. So X is really the length of CB. So I'm going to reference angle A simply because that was the angle that was given to me. So angle A is opposite. So this is the opposite leg. And the one that I know, meaning the leg that I know, is the adjacent. The reason why I'm not using the hypotenuse here is because then I would have 2 unknowns. So I'm really just deciding, am I going to start by finding X or am I going to start by finding Y? It does not matter where you begin. I just chose to start with X. So I'm dealing with opposite and adjacent. Well, if we go back to SOHCAHTOA, the tan function deals with the opposite and the adjacent. So I'm going to say the tan of the angle equals the opposite over the adjacent. I'm just simply writing out the formula. Well, the angle is known to be 42. So the tan of 42 is equal to the opposite, which is X, over the adjacent, which is known to be 70. Now this should look familiar because this is what we did in our last lesson. We're just using a trig function to find an unknown side length. So I'm going to make a proportion and I'm going to cross multiply to find X. Well, my one diagonal, or 1 times X, is X. And then my other diagonal is 70 times tan of 42. So I set the product of one diagonal equal to the product of the other. And as a reminder, I want that 70 to come first so it's clear that it's the tan of 42 and not the tan of 42 times 70. So I put that coefficient in front. Now since X is already by itself, I just put this into my calculator. I'm not using tan inverse because I know the angle measure. I'm finding an unknown side length. So I'm just using the tan. So you'll type in 70 times tan 42, close your parenthesis, and hit enter. That'll tell us that x, or the length of CB, is going to be 63.0 feet when we round to the nearest tenth. Now the last thing we have to find is the length of AB. You have a couple of ways to do this. The simplest is, now that we have found two of our three sides, we can just use Pythagorean theorem to find the length of the third side. The other option is to use a trig function, so it's completely up to you. If you were to use a trig function, then I would suggest, since you have the adjacent leg and are finding the hypotenuse, that you use a cosine. Since you're less familiar with the trig functions, that's the option I'm going to show you, but be aware you could also use Pythagorean theorem now to go ahead and find the length of y. Alright, so if I'm using a trig function, I'm going to know that I have an adjacent leg of 70 and I'm finding the hypotenuse. So A and H deals with the cosine function now. So the cosine of the angle is equal to the adjacent leg over the hypotenuse. So the cosine of the angle, well, the angle is still 42 degrees and the adjacent is still 70. The hypotenuse is y. So here again, go ahead and try this, make a proportion and cross multiply. Since we've practiced this, I want you to see what you can come up with. Go ahead and pause it if you need to. All right, you should have found that AB is really a length of 94.2 feet. If you have questions on that, please make a note in your annotation so we can talk about it more in class. But you would just go ahead and cross multiply and solve that part of the equation. All right, our last example says, suppose your school is building a raked stage. The stage will be 30 feet long. So here's our stage here that's 30 feet long from front to back with a total rise of 2 feet. So here our rise, or how far it is in the back off the ground, is 2 feet. A rake or angle of elevation, remember angle of elevation needs to go up from the line of sight, is better to be 5 degrees or less. And that's just for the safety and comfort of the actors. It's asking us, is this rake stage within the range suggested? So in other words, is this angle 5 degrees or less? Well, let's take a look. We need to find angle x here. Looking at this, we know the opposite leg and we know the hypotenuse. Now again, if you're not sure about the opposite and the hypotenuse, let's talk about that in class tomorrow. But since we're dealing with opposite and hypotenuse, think of your SOHCAHTOA, we must be working with a sine function. So the sine is equal to the opposite over the hypotenuse. Well, the angle in this case is unknown, so the sine of angle x is equal to the opposite, which is 2, over the hypotenuse of 30. Now here we need to decide, are we going to make a proportion or not? Since we're finding an angle, we don't need a proportion. Instead, we're just going to switch the ratio with the angle. So it's going to read the sine of 2/30 is equal to angle x. Oops, I'm sorry. Angle x. So let's recap what I just did. The sine of the angle, so I took the angle and I switched it with the ratio. Remind me, what do I have to do when I switch the ratio with the angle? Does anyone recall? Hopefully you were thinking you need to make that the inverse sine function. So when we're finding the angle, we have to use the inverse. So when you put in your calculator second sine of 2/30, close your parentheses, you should find that angle x is about 3.8 degrees. So that tells us that this angle is 3.8 degrees. They're asking, is this stage raked appropriately so that the angle is less than 5 degrees or equal to 5 degrees? And in this case, yes. This stage is within the suggested range.